Hi, everybody. Welcome to our Esperanto Technologies Job Fair. My name is Raj Khanna. I'm VP of Engineering for VLSI at Esperanto, and I'm joined by a couple of our colleagues in Europe, Nicola and Mark, who will be telling all of us about Esperanto and the opportunities that we have at our European sites. So welcome, and we'll proceed. So Esperanto is very focused on AI, mainly AI inference. There are many data sources that are projecting these markets in AI to be valued at many trillions of dollars. There's one data point of 8 trillion that you see on the slide there, which is a pretty significant number if you're aware of the size of the US economy is around 16 trillion. So prediction that AI by itself is going to be an 8 trillion market is really substantial. We are somewhat unique in the market because we actually have the full stack, silicon to software, and everything is really custom engineered to work together to provide a total solution to customers. And my background is actually a lot in CPU development, high performance CPUs and so forth, but I switched to AI and Esperanto allows me to combine CPUs and AI together. So I think that's a great combination for me. And AI is something that I think is here to stay. I think for the next couple of decades at least, there's going to be really substantial development. And so I think this is a really good place to be and a really good investment in your career. Next slide, please. So what do we have at Esperanto? I mentioned that we have both hardware and software. So on the hardware side, what we have is a very efficient AI accelerator, which we believe is very competitive with other solutions and probably much better than some of the existing solutions for some application cases. We are really much more efficient than GPUs. GPUs tend to consume a lot of power and have latency issues, noise, all sorts of things which limit what they can do. They're really good in data centers, but moving them outside of data centers is actually very difficult. We also have our own ground up software stack, which is extremely well mated to the hardware. And this combination allows us to support new models, right? So there's a lot of development going on in the AI world. Models are continuously changing and growing. And we have a software stack and hardware, which allows us to adapt very quickly to all the innovation that's going on in AI models. Next slide, please. So here is one of the fundamental problems that we're actually trying to address. So you see the chart there with the bubbles on it, which shows how much power is used in just data centers in the US and Canada. And you see that it's been about a 10x growth in about the past 10 years or so. This trend is continuing to the point that normal utilities are really not able to keep up with the demand. And we're actually seeing some large hyperscalers actually going directly to nuclear power plants to purchase their power. So we see that data centers and AI in general is hitting a power wall. Now we can't solve that completely, but we can certainly help by reducing the amount of power that's used by devices. And that's something that we believe is a fundamental value and something that's good for the world. Next slide, please. And here is just some numbers. This is a comparison of essentially power efficiency compared to some other solutions. And you see there that we're on the order of 9x better, almost 10x better than the competition when we look at power efficiency. And we're also looking at latency here, which is another performance metric. And we tend to be better than other solutions on that aspect as well. So those two things coupled together really allows us to be very competitive in some areas, which I'm going to talk about next. Next slide, please. So we believe we are uniquely positioned to scale across many verticals. If you look at some of the solutions that are out there today, they're very limited by essentially the size and the power. In some cases, they have very good throughput, which makes them very attractive for some use cases in data centers and so forth. But they're very limited at sort of the smaller footprint sort of applications where we tend to do extremely well. So if you can imagine a control loop where there's inference involved in the control loop, latency becomes very important. And also the form factor becomes very important. The form factor is very limiting when you start going to use cases outside the data center. Next slide, please. So here's a little bit about our chip. This is a chip that we actually have in production today. We call it our ET-SOC1, Esperanto SoC number 1. It has over 24 billion transistors in 7-nanometer FinFET process. And we've managed to squeeze over 1,000 what we call our minion 64-bit RISC-V vector cores into one chip. The remarkable thing here is actually, when I first heard that Esperanto had over 1,000 CPUs on a chip running at something like 20 watts, I was actually really shocked, right? Having come from Intel and AMD, where that sort of power envelope really it may buy you one core, right? But we've managed to squeeze 1,000, and these are very respectable cores, 64-bit RISC cores with wide vector. I'm going to tell you a little bit about how we managed to achieve that. It's actually quite an achievement. So let's go to the next slide, please. Okay, so how do we squeeze 1,064 CPUs running at gigahertz on a single chip? And also, how do we do it right the first time? How do we achieve that low power? And how do we achieve this supercomputer level of performance? So first of all, our DNA is very much a low power and high performance design company on the chip side. So there are many things that we did, right? There are hundreds of techniques that we use to essentially keep the design as simple as possible, make it hierarchical so that we can manage the data size, and then also focus really deeply on power saving techniques and techniques which allow us to achieve great performance at the same time. So we chose RISC-V as our instruction set, which is a fairly simple instruction set if you compare it to let's say x86 or even ARM and some other things. So that allows us to essentially have less hardware, and less hardware allows us to pack more and allows us to run at lower power. Right? Our software is also designed from ground up, the algorithms, to essentially be very low power and to support wide parallelism. We have microarchitecture techniques throughout as we design our cores from ground up, right? So the instruction set is RISC-V, but the entire design and how it functions is completely our own. And it is custom designed to be extremely low power. We have very low power design techniques, circuit design, library methodology. So the whole low power, high performance trend goes up and down the stack, right, through everything we do. We also have our own IP, which is really customized. I mentioned our Minion core, which is our low power RISC-V core, is designed from scratch. We also have a Maxion, which is an out-of-order big core. We use that sparingly. It is higher power, but much better performance. But we do have that, and we use it on our chip for essentially some self-hosted sort of applications. We have our own NOC, which is, again, extremely low power. We consider it to be about twice the power efficiency of commercial NOCs. We've developed that internally. And then what I call the Uncore is our own cache complex. That's also very much a custom design that supports many different use cases, from AI to HPC to many other things. So all of that combined is how we get our shocking power and performance numbers. And I think it also makes for some very interesting engineering work. I think our engineers really enjoy doing the from scratch sort of work. And the level of innovation here, I think, is really remarkable. And I think our engineering team really enjoys doing this kind of work. We do all in-house design verification. We have a great verification team. We try to limit the number of time zones so that we're not spread out too much, and we minimize sort of late night meetings and very early meetings. I think we've gotten into a pretty good rhythm between our US and our European sites at this point. So we try not to stress the workday too much. And again, having our own software systems in VLSI really allows us to innovate across all of the domains and allows us to make decisions really quickly and move fast. So if you're looking for a company where you can come and do things, remarkable things quickly, learn a lot, I think all of this together makes Esperanto a really good place to be. Next slide, please. And with that, I'll introduce my colleague, Mark Lupon, who's going to tell us about the software side of the company.
Yeah, thank you, Raj. So I'm Mark Lupon. I'm the head director of the software AI. And as Raj was mentioning before, we have a many core architecture based on RISC-V. And that's really good because that allows us to attack the parallel programming problems, and it's good that AI it's one of these kind of problems, so that's the reason why we are doing so good AI, and especially having a sophisticated memory hierarchy and special core connectivity that allows us to gather all the data closer to the cores, allows us to be very efficiently when we write AI code. As Raj was mentioning, low energy consumption is critical for us, and it's critical especially if we want to go to the edge where the industry is moving right now. So there we have small power envelopes, and we need to be low power if we want to introduce on that market, and Esperanto has exceptional qualities to do that. So on our side, what do we do in software? We make sure that all the next AI models, new algorithms that are there are able to run in our devices. Right now we have an ML toolkit that is functional, high performant. It's available today, so you can try it. If you go in our website, we have machines dedicated where you can basically run models in the form of chatbot. And what's most important is that we do constant innovation. So we look to the future, we look at the roadmap, and we co-design everything from a software perspective. So we know the applications, we know where we have the bottlenecks right now. So we give feedback to the hardware team from the software perspective on how the future products are going to be or how they should look like. And that allows us to unlock generative AI at the edge with smallest power budget in the future market. So next slide, please. So if you take a look at how the ML stack looks right now, we basically take the models, conventional models, foundational models from Hugging Face, and basically we fine-tune them targeting different markets, so different applications. We quantize them and we optimize them so they fit better in our software stack. We export them so they can run correctly in our software. And finally, we precompile them so when we want to run them, we don't have to suffer any kind of overhead. We place those models, precompile it in Hugging Face, and then when we want to execute them, we use standard tools like can be Onyx Runtime, which is a generic ML framework, or Oyama, that's a third-party application. All of this comes to our software stack through the runtime orchestrator. It runs in our system that is populated with many of our devices, and all the executions then go back to the user. So we advertise all of our products in our LinkedIn space, so you can take a look there if you are curious about them. We have a chatbot that is available. Basically, this one small language model running in a single card, and you can see how it works right now using one of the devices. And also you can see the optimized models that we placed in Hugging Face in case that we are curious. So next slide, please. So in the software team, we have a lot of opportunities. We to touch different things, and we need different level of expertise. So we seek data scientists who know how to fine-tune models and also apply optimizations techniques. We also look people that has some experience with ML frameworks. They know how to run efficiently models across different devices. We are looking forward to hire a lot of AI compiler people that knows how to optimize things, not only at the kernel level, but also across all the nodes of the network. We are looking for people that are interested in building applications on top of our stack, basically moving or using AI in different markets to generate progress on those markets. And then people more product oriented or SQA oriented that validates our products and also gives some customer support. Next slide. So if we look into detail, I would like to present a couple of opportunities that we have. One is an AI application engineer. So if you are passionate about AI, you would like to know how things run, which are the topology of the networks, how the topology of the networks affect performance. This is the position that you should take a look. Basically, in that position, you will be able to characterize the last novels LLMs and VLMs. You will be able to understand the internal topology and check how this topology affect the architecture that we have underneath markets here: healthcare, smart homes, robotics, automotive. And also you will check alternatives to the conventional foundational models to increase accuracy. For instance, you can apply RAG to increase that accuracy. We're looking also people that knows how to optimize models, and here quantization, speculation, KB catch compression, there are things that we're looking forward to work with, and also implement the pipelines to be able to build applications and move these applications to the domain that they were going to be useful. So to apply for that position, you don't need to be an AI expert, but you need to be passionate about AI, and also you will also have some knowledge of the internals of a microarchitecture. That would be good also position to apply with. So next slide. Yes, here we present a position that's more about optimization. So at the network level and also at the kernel level. So I was mentioned before, we have a massively parallel accelerator, and what we want is to run as fast as possible in as many cores as possible, hitting the maximum efficiency all the time. So in that position, you will work on that. And again, this is no need to have AI expertise, but here what it's really good is to have microarchitecture expertise and also having worked on optimization in the past. The good thing of this position is that you will be heavily involved in the design of the next architectures for our chip. So we will be able to define the ICE extensions that for new data types that will help to accelerate things in the future. Also adapt our existing compiler to use RBP extensions, identify bottlenecks, and then provide feedback and propose even solutions to gain efficiency. So again, we are looking for compiler engineers, application engineers, and if you are interested, please let us know. Next slide. So what we believe that we have here is a unique opportunity. So you will be able to work on applications for different markets, and that would allow us to move generative AI at the edge, not only in the cloud, but also it's called physical AI, or basically populate the world with a lot of devices that are able to run AI models. Uh, we have a highly experienced engineers, so we have experience in many domains. And what we have is a cross-functional team that can help us to co-design products and really great work environment. We not only have one product, but we have a roadmap of products that we're developing right now. So you will not only see the present, you will see the future in Esperanto. And we have in Europe offices in Barcelona and Serbia, and really a worldwide culture policy that I'm going to explain in the next slide. So one of the nice things of Esperanto is that it allows a hybrid work environment. That means that some people comes to the office every day. There's some people that never comes to the office. There's some people that won't just work once or twice per week. We're completely flexible with that because one thing that really matters, and Rachel was mentioning that before, it's the work-life balance. And here I would like to thank the US mates because they managed to do early morning meetings that allows us to do afternoon meetings at, let's say, hours that make sense. In the past, in other companies that I was working on, that was not the case, and that was a headache. So that's something that I really liked from Esperanto. Also, that we have an open door to the CEO, not only CEO, all the executives. So uh, I normally talk every day with executives. Engineers talk with them, they talk with me. So there's a lot of transparency across the whole company. And what's more important, it's the experience that you will learn if you work with us. The fact that we are a small company, that we touch a lot of components, that we have hardware, software, systems, everything, the whole stack, uh, will allow you to learn a lot in a really small amount of time. So I've been in Esperanto 6 years. I think that in these 6 years I learned much more than uh, my whole life. So it's something it's doesn't have a price. And the other thing that's important is that if you join us, you will have a role, you will have responsibility, you will have something to do, and that will impact directly our work. So we are not so many. We would like to be more. So if you're interested, again, please join. And with that, I will just give the opportunity to Nikola Rajovic to present the work that it's available in Serbia.
Okay, thank you, Mark. Thank you, Raj. So I'd just like to remind all of our participants to send questions. There is a question box in the top right corner, and you can submit all your questions, which we will address later. So I'm here. Thank you, Mark, for the introduction. I'm here on behalf of Belgrade office, one of Esperanto offices in Europe. We're established in 2019 by Dave Ditzel, who is our CTO. So there is talent present in our office, and having said that, we have three different teams that are dealing with different topics in a chip design area. So we have architecture team, design verification team, and system software team. So I'd like to, for the next slide, where I will show from idea to a chip, how we fit with the roles that we are having in Belgrade office. Next slide, please. So what happens as with any other chip, also our chip for AI inference, there is an architecture specification which needs to be written such that people who are designing the chips know what to design for, what are the end goals. So, and then the RTL designers are turning those specification into the code. but all of that needs to be verified, tested for functionality, tested um, whether it's in compliance with a spec. So that's part of the work that we are doing here in Belgrade. Also, physical design comes after the design verification. Frankly speaking, these phases are happening in parallel, but if we want to look as a flow, we can say that physical design comes after, and once the physical design is finished, we have a tape out. Our team also contributed to the silicon bring up, which happens after the tape out. And of course, we take a part of celebration, which happens. So we had a big celebration because our chip worked at first. We didn't have any showstopper bugs. So that means that we all together, the entire Esperanto force, worked pretty good actually to have a zero bug silicon. So apart from these roles that I mentioned here, which are marked in squares, so we also have a system software in Belgrade. What it does, it provides the basic software in forms of bootloaders, runtimes, device drivers, the software that runs on all those 1088 CPUs that Raj mentioned at the beginning. The software which allows the models that Mark was explaining got distributed among all our 1088 cores. The software which allows uh, all our peripherals that we have on the chip to be brought up such that our accelerator card can work in a computing system like any other accelerator. So take a GPU, for instance. So we do exactly the same in the system software. And guess what? We are looking for new colleagues in some of the roles that I mentioned. So here in Belgrade. So can I, next slide, please? Okay, so one might be wondering, how is life in a chip design company? Well, I'm as Mark, the same as Mark. I'm 6 years with the company. So what I do appreciate is a hybrid work environment where we have some days that we are in the office, some days we work from home. So we could establish a good work-life balance thanks to understanding for all the colleagues across the zones. We do not have many unneeded meetings, so we use the other ways of communication and work organization. So work-life do exist here. Apart from the open doors from CEO, which is really important, uh, every person is a company. Every person has an important role at Esperanto. You can reach anyone. You can reach anyone because once you are in Esperanto, you become an owner of a particular part of the chip, be it software or hardware or whichever area you may think of. So you need to communicate with your colleagues, and everyone here is really here to fulfill the end goals, which is putting a chip on the market. So what I can say from my own experience is that being here for 6 years, the same as Mark, you can learn a lot. So if you're looking for an experience where you can really sense the Silicon Valley spirit in Belgrade, this is the right place to be. So next slide, please. So speaking about the Silicon Valley spirit, so how does it reflect, for instance, on the RTL design roles? It is not any different than in any other company which does RTL design in-house. So as an experienced RTL engineer, you have the skills needed to design high performance circuits. And essentially that is just what you need to work at Esperanto as an RTL designer. So we also use industry standard tools and languages. So no surprise there. We tend to well define our specification such that the designers can pick up from the architecture following the clear specification. Uh, all our hardware is made modular and essentially you would be implementing the regular hardware primitives, different control units, pipelines, memory interfaces, everything that you already probably seen in other kind of chips. And of course, CPU and SoC designs have comprehensive test plans, and there is of course a team which you would be working together, just like in any other roles that you may expect that to happen. So next slide, please. I'll speak about the verification. So speaking about verification in Esperanto, we use the standard verification languages and methodologies. Of course, that is 99% true, but every company has its own piece of spice. So we spice it up with some in-house things, which make our verification efforts faster. Just to remind you, we had 0 bugs. So that speaks a lot about both the design and verification team. So we tend to have clear modular test plans. So everything is well organized. So with that breakdown, it's easy without to reach the goals without being overwhelmed by a huge system as an SoC could be. So we tend to make to work with verification IPs, with reusable verification IPs. So and this let us focus on key features which are unique to the SoC or CPU without needing to verify everything from scratch. So no time wasted there. We champion the functional coverage. So if you're already familiar with these concepts, there is nothing new here. We implement those concepts in our flows. And what I would like is to underline is that SoC and CPU verification are really exciting fields. I can speak from my own experience. I was not a verification engineer. I'm a computer architect, but I took on that role because I found it is very exciting and find an opportunity to even expand my skills and understanding of the system. So just to remind you that if you have any question, you can use our question box. We will answer those towards the end of this webinar. Next slide, please. So speaking about the positions and about how they look like, we have plenty of open positions related to both software engineering and VLSI engineering. Some software is mostly located in Barcelona, as Mark pointed out, the AI compiler and AI optimization and integration. So for the system software roles, we have them in Belgrade. Then from the RTL perspective, we have core processor design engineer positions. We're looking for a manager. We're looking for a DevOps in 2 places. We're looking for both senior and junior verification engineers, as you can see on this slide. For a full list of open roles, you can go to the link on the bottom of this particular slide. So even though if a position is not listed, you can go over a general application. So maybe you are fit for a position that we are also envisioning in the near future. So next slide, please. And I would just like to thank you for your patience, and I would like to thank Mark and Raj for their presentation. This would conclude our job fair presentation. So if you have questions, as I said, please submit them through a question box. Thank you very much.
Some questions have come in, so I can go ahead and start reading them now. The first question I will direct to Sam, who is hosting this job webinar. What if I don't see a job posting, but I'm interested in applying? Sam, could you answer that?
Yes, hi. So I'm Sam. I'm the HR generalist at Esperanto based in the US. I'm currently filling in for Sue Depositar, who's in Global People Operations, as she was not able to attend today. So I'll be answering any HR questions that are coming in. So, as Nicola mentioned earlier, if you go to our careers page, you will see at the very bottom there is a link that says general application, and you could submit your application and resume there. Thank you.
All right, next question I will also direct to Sam. What if I want to work remotely?
Yes. So most of our jobs, if not all, are hybrid, which is partly working at office and at home. So in some cases, there may be an opportunity to work remotely, but it depends on the specific role and the team needs.
All right, the next question I'll send to Nicola. This person says they're here and with a group of students that are at a Master of Embedded Systems and Algorithms at Faculty of Technical Science in Novi Sad, Serbia. Currently, they are working on a project for their master's thesis, which is hardware implementation of multi-core RISC-V CPU, and they're formally verifying the whole system using Cadence Jasper Gold. They are interested whether there are any positions for juniors or internships, either for UVM functional verification or for formal verification.
Oh, so thank you, Jenny. So I think that as we already said, apart from the listed position, which include the junior and senior engineers for our IO unit, this would fall into a general application. But I would encourage people to get in touch with some of the contacts that they see on the current slide, which is being presented. Since they are from Novi Sad, University of Technical Science, they can get in touch with me, and we can speak about that in more details. Because their project really sounds exciting.
Thanks, Nicola. The next question I will direct to Raj and probably Mark as well. This person says, I am a first semester MSEE student at SJSU. I wanted to ask if you are hiring interns for chip design or DV roles. If yes, what qualities in an intern would be a good fit?
Yeah, so we do have an internship program. We tend to take interns typically during the summer. Sometimes we'll do them in other seasons, but typically summer is our intern season. And what we look for is really, and Mark is going to tell us about the software side of things, but on the hardware side of things, we look for essentially a good VLSI background, interest. We look for a lot of passion. We look for people who have really good fundamentals and want to have essentially a long career in VLSI. And we'll work with them. And our aim when we bring in interns is to really find people who are passionate, who we want to work with longer term, and hire them eventually when they come out of school and they become available. And our software team actually has a much bigger internship program. So Mark, if you want to tell us about that.
Yeah, so we have a lot of interns, both in the data science team in the US, also in software team in Barcelona. As Roger was mentioning, normally there are summer internships that could be extended during the day as a part-time jobs. We have people in Barcelona that study and at the same time work a few hours for us. The same happens with the US. We tend to hire them as summer interns full time because training process is faster, but then they can work part time with us. And I think that it's valuable. Something that I encourage everyone to do. People learn a lot during these internships. Ourselves learn a lot from the interns as well, and they are able to produce a lot of stuff. And I was surprised by the work that some of the interns can do in just 2 months. So yes, we are definitely open to internships, and we basically try to advertise those internships whenever we are going to job fairs, or we try to hire people from universities.
Great, thank you guys. Next question. Hello all. First of all, thank you for hosting this. I have work experience optimizing computer vision applications on a heterogeneous stack, RISC-V CPU and SIMD VLIW based DSP and neural accelerator. I have experience with techniques such as quantization, pruning, MAS. With current LLM architectures, many optimization techniques arise, KVC, speculative decoding. And I don't have experience with them. Am I still a potential candidate for an AI-based position? I think this would be to Mark as well.
Yeah, so that would be an excellent candidate. So first of all, nobody lives with all the knowledge, so you need to learn, and Esperanto is a good position, good company to learn. So and also that person has experience in RISC-V. That's really good for AI compiler, generating kernels. Has some experience with optimizing ML models, so it's also a good candidate for a AI engineering. So yeah, definitely, if you like this presentation, if you like what we do, please go ahead and submit your resume with us.
Thanks, Mark. The next question I have is, if I were to join the system software team, what opportunities would I have to gain exposure to different aspects of the AI accelerator stack from RTL to ML software? I think this is Mark as well.
Yeah, so system software is a really interesting position because you are able to touch almost everything, right? On one hand, system software needs to understand microarchitecture and also the architecture part, because you need to program what's happening in the device. For the products to come, you need to simulate all of this through either a functional simulator or a cycle accurate simulators. So you will be able to just see RTL signals, understand why these signals happen at that precise moment of time. Sometimes you need to fight with deadlocks, and to basically understand why these deadlocks are created, you need to understand microarchitecture. So definitely you need to iterate with the RTL team. And then from ML perspective, again, for next generations and also for the current generation, what you want is to minimize the amount of time that there is between one kernel and the other. So you need to understand which are the problems of basically queuing kernels and queuing models and how to run them efficiently, concurrently. So you will also learn about ML, you will interact with ML engineers, and you will be part of almost everything. So it's good.
All right, the next question I have, I'll direct to Raj. Does Esperanto hire freshers? I am an MSCS grad student with internships, research papers, and a fellowship, but no full-time experience. I would love to join Esperanto when I graduate in June 2025.
Yes, we would certainly consider it. It really depends on your background, area of study. If you've done higher studies in particular areas that are interesting to us, then we certainly consider it. We tend to have a more senior team. It's a smaller team, but we will have some openings for freshers as well, or individuals with a couple of years of experience. We will have some positions for that.
All right, next question. I'll direct this one to Sam. Does Esperanto hire talent only from the US, Serbia, and Spain? Can people from other parts of the world work at Esperanto? If yes, then does Esperanto help new hires in relocation? Sam, we can't hear you if you're speaking.
Oh, thank you. Yes, we will look at applicants at other countries in a case-by-case basis. But in regards to relocation, yes, Esperanto does offer relocation support. However, these are also determined on a case-by-case basis as well.
Okay, the next one I'll direct to Raj. Where is firmware done? Is firmware hybrid?
Yeah, so that's firmware is a part of our software team. We have essentially in US and Barcelona. And Mark, if you want to clarify that
Yeah,
function.
sorry, we'll
Yes.
direct that one to Mark.
Yes. In fact, the two teams that work more than firmware are Serbia. We have four, I think, system software engineers there, and then we have a team as well in the US. In Barcelona, we give support, but we don't develop so much firmware. We used to do that in the past, so we can also do it. So yeah, in all locations.
Would you like to speak to that, Nicola?
Well, I can only add, so Mark just, I think, answered it correctly. So yes, we do. Some parts of the firmware is Serbia, which is related to the system software. And an ideal candidate for that position, if it's coming as a junior engineer, should have a great track record coming out from the university, should be like a real talent, or should be an experienced person with, again, a good track of record and skills that we actually require for the position. All our system software openings do have a pretty good description on our website, so not to go into much of the details, but please feel free. And if you're having even some skills beyond of those listed, that it's even better. So maybe some of the skills are not exact but compatible. So yeah.
The next question I'll also direct to Nicola. In Serbia, if we apply for internships or junior positions, do we need any experience?
For internship, I mean, should be. So since we still don't have an internship position open at this very moment, so may happen during the summer. But yeah, apart from prior experience, which is probably non-existent for an intern, we should have at least some track of high interest in the field or some university projects, and also depends on the curriculum which candidate attended. All of those can be discussed. So pay attention if there are openings and send your curriculums. Be as detailed as possible so we do not reject detailed CVs. So feel free to add all of your relevant experience.
Okay. Next question. This I'll direct to Sam. Does Esperanto hire talent only from the US? Oh, wait, this one I think I've done. um, what does the career growth path look like for a hardware designer, and are the paths to transition into other roles such as system architecture? This could be a question for Raj.
Yeah, so depending on the level coming in, it could be more of a junior position working under, supervised by a more senior person. We've actually had a number of people who started out with a couple of years of experience who've now grown into leadership roles, either technical lead or even manager roles. So it really depends on how you come in. And because we're actually a small company and we have a very broad set of things that we do, we actually do have many cases of people who started out doing one thing, like let's say design verification, but now are doing architecture or now are doing software or something else. So we actually have quite a bit of mobility. I think much more than you would see at larger companies. And we encourage people and help them develop talent and interests, and we've done that with a number of people already. that's something that I think we do quite well compared to many other companies.
Thanks, Raj. Next question, I think, is directed to all three of you, but we'll start with Mark. What does a typical day look like for a team member working as an engineer?
Yeah, so I would say that it's 20%, maybe less time in meetings, 70% implementing. We have, as Nicola mentioned before, it's pretty clear the work that needs to be done. It's pretty well designed. The requirements are clear. So most of the time you will be designing, implementing new things, validating these things. And then I would say 10%, it's sharing knowledge with others, either presenting your work, attending a presentation from somebody that has completed some milestone, reading new things, brainstorming stuff. Yeah, so most of the time it's designing, implementing, and doing real work.
Nicola, would you like to answer next? If it's any
Yes.
different, I guess, than what Mark said.
Yeah, so that goes pretty much along with what just Mark pointed out. So depending on the day, meetings are around 20% of the time. These are not the meetings just for the sake of the meetings, but we discuss things as a part of collaboration because we foster collaboration among our engineers. So there is a lot of things to do. We try to schedule the best way to deliver all of those tasks. So apart from that, there is also engineering time you devote to your tasks. Some people do establish focus hours during which they are not that much interested for communication, but they would like to focus on their job. So they need like a slice of 4 hours to be fully focused or something like that. Also, there is a time of the day which we use for lunch. We need to eat, engineers eat as well. So that's about it. That's about how an engineering day looks like. Of course, coffee and everything. So they're like a rule.
Thanks, Nicola. All the essentials. Okay, next question. I'll direct this one to Raj. How are your teams organized? Do you follow any kind of methodology in your day-to-day work? Example, agile.
Yes, so the way we're organized, we have multiple sites. We have 2 sites in the US, Mountain View, and we have a Portland site. Portland site essentially does what I refer to as the Uncore, all of our cache complex, NOC. Our Mountain View site on the hardware side is really sort of an integration site. We bring together all the IPs, the NOC, the minion cores, the IO complexes, various IPs that we've purchased, and essentially put it all together. And our Barcelona site is really key in developing our the minion core. That's all done pretty much in Barcelona and Serbia. And Serbia has recently taken on a task of doing our what we call our IO Shire, the IO complex. So that's a great responsibility that they have. What we follow as far as any sort of it's not a formal agile process. We tend to do monthly goals as part of the VLSI team. Our managers get together once a week or so, and we figure out how we've done. We reconcile, whatever our goals were. We set goals for the next month, and then we have sort of an overall plan what we want to hit in 3 months, 6 months, and so on and so forth. And we try to adhere to that as much as possible. We do use Jira. We do use program management methods. I would say it's loosely agile based, but we don't follow it exactly.
Mark, do you want to answer that in terms of software?
Yes, in software we use a flexible Scrum, I would say. We define our work on a sprint basis. This is 3-week sprints. Each sprint has its own tasks. We basically track the work using Jira. We try to complete as many tasks as we planned. Sometimes happens, sometimes not. If it doesn't, we do kind of a postmortem to discuss if we want to reschedule things, if we postpone some of the things, and etc. We do sprint tracking every week in working groups, not across all the members of the software team. But we are kind of flexible in the sense that we don't have Scrum Masters. Everyone is the owner of their own dashboard. So in that sense, it's not a strict agile.
I'll do one more question as we only have a few minutes left. If I didn't get to your question, I apologize, but we'll just do one more. This one I'll direct to Raj. In what way does our company encourage self-learning? Does it cover costs of online courses, attending conferences and meetups, etc.?
Yeah, we do. We do occasionally go to conferences, and if you're representing Esperanto, then certainly the cost would be covered. We do like to be present in industry forums, especially a lot of the RISC-V sort of forums. We have very good representation on some of the RISC-V committees. We've actually presented, we've proposed new architecture there. So we're quite active in areas that make sense for us. And if we have employees who are presenting, like our chief architect recently presented at a RISC-V conference. That was a great opportunity for him, for his career growth, and also for Esperanto to show what we have. So yes, we do encourage those sorts of things. And but I think most of the learning will be what you need to do your job. So this will be usually something that your supervisor will recommend to go read or go learn something. Most of that is sort of informal. And then, conferences and so forth would be kind of an added bonus.
That's the end of our Q&A. Nicola, if you want to close.
All right, so I would like to thank all our attendees. I would like to thank Raj, Mark, Jenny, and Sam for executing this job fair. So thanks everyone again. And if you have any questions, please feel free to submit them to any of the addresses you see on your screen. So Raj, Mark, myself, Sue. So feel free and we'll try to respond. And that's it, folks. Thank you very much.
Thank you, Nicola.
Yeah,
Thanks,
thanks,
everyone.
Nicola. Thank you, everyone.
Bye.
Bye-bye.